Okay, good afternoon, everyone. So we now have the arduous task of keeping you entertained for the next 45 minutes, right after lunch. So no better topic than talk about university program and the courses that we teach and the projects that we do. So anyway, welcome everyone. I am Professor Vijayan Sugumaran. I work at Oakland University. I am the chair of the DIS department, Decision and Information Sciences. So I want to take a few minutes to talk about our program, and then I have three lovely students that are going to talk about one of the projects that we did. So we do a lot of industry-sponsored projects, both for profit and nonprofit organizations. And so the students are going to talk about a project that we did for a nonprofit organization called Secondhand Hounds. So Secondhand Hounds is an organization that's in Minnesota. So they rescue animals, find foster homes for them, and so there's a lot of data that they have to deal with. But unfortunately, they don't have good tech support, and they're all volunteers. And so we did a nice project for them. So the students will kind of go over some of the details of that project. So anyway, so to get started, oops. Wrong direction. So I am the chair of the DIS department, which is in the business school. So we have 4 departments: economics, marketing and management, accounting and finance, and DIS, Decision Sciences department. So we offer a couple of undergraduate degree programs and then a couple of graduate degree programs. And so our undergrad programs are in MIS, Management Information Systems, and then the other program is Operations Management. So within the undergrad program, we have specializations, meaning that students can pick some electives so that they can specialize in a certain, sorry, I have to be in this location, that's it, I can't move, okay? And then we also offer a few minors from my department. And then obviously there are other minors and programs in the entire School of Business. At the graduate level, we have 2 master's programs. One is MS in Business Analytics, and the other program is MS in IT Management. In IT Management, students can specialize in cybersecurity, so that's an option that we provide. But they can also focus on a general MSITM, meaning they can be, web app developers or database kind of a person. So they can put a program together based on their interest. So they can come up with their own plan of study, and then they can kind of brand themselves. We also offer a couple of graduate certificates, one in business analytics and the other one in information security management. So the graduate certificate programs, and actually both the MS in Business Analytics and ITM, we would offer an online version starting from fall 23. So, a lot of people ask, do you have online programs? I guess the world is kind of moving towards the online direction to some extent. And so, to meet the demand, so we're going to offer sort of a both hybrid version. So if somebody wants to come on campus, take some classes, you're welcome. But if you want to stay fully online, that's possible as well. So students would get to pick and choose the modality that works for them, okay? We also have MBA program. We also have Masters in Accounting. We just started Masters in Finance. And so in the MBA, there are a lot of concentrations available. And so we focus on operations management, business analytics, and so on and so forth. We also have an executive MBA program, if anybody's interested. Always looking for good students to be part of our executive MBA program. Sorry, this is a brochure, it's a busy slide. So basically, both the MS programs are 30 credits, 10 courses. It's broken down into 3 sections, if you will. The first section is IT core. We want to make sure that people have a good background in database, good background in project management, and then also some introduction to business analytics. So that's the IT core. And then we have a set of electives that they can choose from. So we have courses, advanced database and big data management, a course that I teach, from which this project actually got started. I also teach another course on deep learning and text analytics. And then we have lots of other courses like forecasting, R and Python. So we offer a number of courses, electives that people can pick and choose so that they can build their own kind of branding and career that they envision. And then to top it off, a capstone course. And so we actively look for projects from the industry. And so all of you, please help us. So free labor, right? So there's always things that you want to do, you plan to do, but you don't have the time or you don't have the manpower. We are here. So please knock on our doors. So it works both ways because, students get a real kick out of doing real world projects and that they can kind of gain some experience that we can't offer in a classroom setting. And so hopefully at the end of the project, they deliver something of value to you, right? And so that's one of the projects that the students are going to talk about. And so we really value experiential learning. And so to the extent possible, we reach out to the community and seek help. And so if anybody has a project, please let us know and we'll be happy to work on it for you. Same information, at least a version that you can actually read. So I kind of talked about this anyway. So some of the interesting aspects of our program, even though we are in the business school, our programs are STEM designated. STEM stands for science, technology, engineering, and math. So for international students, it actually makes a lot of difference. Any international student coming to US, after they finish the degree, they get 1 year practical training, meaning they can work for a year. If the program is STEM designated, they can extend that for 2 more years. And so that's very valuable for students coming from abroad. So one of the first questions that they will ask is your program STEM designated? Typically engineering school, technical schools have the program STEM designated, not so much in the business school. But since our program is mostly technical, so we were able to get that designation. So it makes a lot of difference for international students. Like I said, we value experiential learning. We try to get a lot of internships, and then hopefully students would get placed where they're doing internships in the summer. We also get our students to participate in a lot of the competitions. We use SAS quite a bit. We use SAS Via. Dave knows everything about SAS. He's a good supporter of our program. So we use SAS in 3 or 4 courses, and so if students take that set of courses, they actually get a digital badge from SAS automatically. So we have a very strong relationship with SAS. So in our program, we try to make available all the tools and technologies that are out there in the marketplace so that at least our students know what they are, when to use what, and apply it the right way. So we value experiential learning quite a bit. And so the MSITM, the IT management program, is also very similarly structured, 30 credits, core, electives, and capstone. So within the MSITM, people can specialize in cybersecurity if they wanted to as well. So we have a set of courses for that specialization. We also offer graduate certificates. So this is sort of like a halfway program. So a lot of times people say, well, I already have a master's or I don't have the time to do a full master's, but I do want to get some exposure to analytics. And so we have a graduate certificate in analytics where it's a 5 courses, 15 credit. So it takes you halfway through the program. And then, if they want to continue, they can as well. If not, at least they get the graduate certificate in business analytics. So we used to offer a cohort version of this to lots of the companies, including Stellantis. So we do lots of projects for different companies around here, Southeast Michigan, and beyond as well. And so our team is going to talk a little bit about one of the projects that we did for Secondhand Hounds. So that's pretty much it, my spiel. I'll turn it over to my students. Thank you.
Hello. Professor, can I have that?
Yes.
Thank you.
If you can switch over to the other. So now is the time I'll do a little song and dance.
Okay. Hello, everybody. I'm Shalini. This is Vasudha. This is Andrei, of course, our professor. We are here to present Data for Good. I'm going to talk about what SSH is or what that organization has helped us, how we had imported all the data, what sort of pre-processing we have done. The rest of the project will be taken by Vasudha and Andrei as follows. So this is us. We were 6 in our group. James, Fat, and Zara unfortunately couldn't make it to this event. So the 6 of us split up the project into 2. Each teams took a specific ask and we worked on it and we submitted, but the core of the project still remained intact. Carrie, Maggie, and Tashina were our point of contacts at SSH, so they helped us gather all the information. We were sitting on weekly calls, gathering information, so it was fun. So what is SSH? Professor did give you a brief about them. They're located in Minnesota, non-profit organizations for helping animals that are either old enough or they rescue them from kill centers, find foster parents, try to set them up for adoption if those animals are in dire need for care. They set up veterinary visits, whole sort of thing that happens behind the screen when an animal comes for adoption. Let's say you have an animal for a couple of years. For some reason, you're not able to take care of that animal. What happens then? These guys step in. So they take the animal, try to see what, does the animal need any help in its life? If so, take them to the hospital, schedule all the visits, get the animal well, give them a proper place. In the meantime, there's somebody called a foster who hosts that animal for a certain amount of time until the animal gets better. So a foster can cater to one animal or several animals depending on their capability. So, and then once the animal gets better, they find an adoptee. Let's say the animal is not going to get better, it is at the end of its life. Then there is a suitable home or a care center that provides the animal the needed care that it needs towards the end of its life. So that's predominantly what they do. So how they do it? From the business perspective, you're going to get an animal, so how long is it going to stay in your care? Who is going to adopt? What sort of animals are going to get adopted? And which animals get adopted quickly? And how do cats do? How do dogs do? Are there any other animals in this group? We have even had turtles and reptiles in this group. So which animals are preferred? What sort of flyers do they do? Whom to reach? Which area to reach? Where are we getting most of our animals from? That's where we came in. So where did it all start? Of course, with Professor, with our data analyst, with our class. So this ended up being our course project for both of our teams. So we met with Carrie, my team, me, Vasudha, Zara. We met with Carrie. The other team met with Maggie mostly. So our core was, they had data in Excel sheets, in Google spreadsheets to be precise. They had few things in their head. They knew it because they were doing it for a very long time. They had data inside Rescue Group, a website which had data in 2 formats, JSON and XML. So our job was to actually bring all of this together. So we had several calls in which the data in their head, we actually asked them to put it on paper to actually know that what we are supposed to do. So we then took all those data and then I'll explain you how we did it later, but we did take all that data, put it into at least a mapping, an XML, a mapping, and then we put them all into database. So that was step 1 for us. Our step 2 was there was a simple report that they had to do. How many cats did they take in? How many animals taken? What was the age category? They were actually doing all this count manually. And it was taking them several hours. So our second ask was to make this simple for them. Click of a button, you get a report. So first we had to organize the data. Then we had to do that report for them. The third one was, whom do they actually reach out to or make their flyers for so that the animal gets adopted quickly? So because every day the animal is in their care, they are paying for the animal and they are paying for the facility and everything. Since they are a non-profit, money matters. So they wanted to make that process quick. So how could we help in that part? So this is where it all started for us. So the next thing, the report that they were manually counting, oh, I'm sorry. Oops. I'm sorry. So the report that they were manually counting and filling every month is here. The report that we made, this one we did in Power BI. So we actually automated it. We created several tables and everything. So from A to B, this was, the second ask was, the first and the second one was taken care of here. Going on next. So what were our challenges? Of course, the first one was some of it was in their head. So everything had to be brought to paper first and then loaded in a database. But like I said, they were in different sources, multiple sources. Some, in fact, there were two things. One was veterinary information. So most of these dogs needed veterinary care. Unfortunately, we couldn't get the APIs and everything for that. So that part of the story was we kept it as a snapshot of time. So we kept that. The other thing was the rescue groups. The rescue groups, we had two options. One is we had to download it as an exports, which was an XML format, for which we had to do a data refresh every day. So if you see here, we are doing an auto refresh every day. We're getting the API, we're getting the exports from their website. So the API returns a JSON file, the export returns an XML file for us. We had to process all that data, bring them into a common format, and then store it in a MySQL database on Amazon Web Server, and connect Power BI. Unfortunately, at their place, they were not technical. There was only one tech person who will take care of everything. So to get all of this information from them took us a lot of time. But then we actually, beyond our project, some of us actually helped them to set it up at their place so that all what they have to deal with is Power BI, because most of them are familiar with Excel. So Power BI was an easier transition for them. And the setup it was a one-time setup, so it was much easier on them. So this is our code. I'm sorry, I won't be able to explain every line of it. So this is how we sent API requests and XML exports every day. So it was, we had automated it. It was all done in Node.js. One of my friends, Fat, who currently couldn't be here because he had a family emergency. So he did most of it for us in the coding part. So he helped us with everything. So it was all coded in Node.js, and so here is a look of it. And then this is our database schema. We created multiple tables for the type of report that they wanted. So the data was organized in several ways. So we wanted to bring it into the shape that we wanted. So if you look at this table, this had most of the information we created using DAX. I'll explain it in the next slide. But we brought it all together as dimension tables, fact tables, and split it up so that we can consume it and provide them the necessary analytics later on. So this is one of the usages of DAX. Here. So how we created a simple dimension table, and these are all the tables that we had ended up creating for them. Another DAX where we created a separate table. This is called a summarize function for DAX. So we summarized the table because this had all the information, all the specific counts that they had asked for on a monthly basis. So we gave it to them. This helped us do it. I'll pass it on to Vasudha.
Thank you. Thank you, Shalini. So I'm going to be walking you towards the Power BI dashboards that we created for SSH. So this is a landing snapshot of year 2022 data for SSH Secondhand Hounds. As you can clearly see on the left side, There are 2 gauges. So this basically explains how many animals are rescued in 2022. Rescues means animal intakes. And what is the target that they have defined for the animals for the year of 2022, because this was done in 2022 April. So by far the data was 522 animals has been rescued. Their target was 3,000, and they were supposed to get like almost 4,000 at least animals for that particular year. And the next thing they wanted to see was what is the adoption fee, like how much are they getting by year or quarter by quarter. So this is for year 2022. So this is by far that they have collected. This was in April 2022. So 223K was collected, and their target was defined as 1 million. The next snapshot here you see is between animal intakes and outcomes, which is basically rescued animals and animals adopted. So how far they are going towards the different years, like from 2017 to 2022, how they wanted to see, they wanted to analyze their data so that they can understand why the animals are not getting adopted, what is the process, why exactly, what is the problem behind it, and how they can compare year by year comparison and why it's going down. So as you can clearly see, after 2017 it went down till 2019, then it went up again. After COVID it was going down, and 2022 was actually the worst for them. So this was in terms of the animal intakes and outcomes. So this is basically a snapshot just to explain like animal adoption by different age categories. So we had like 2 categories, babies and adults. Babies were less than 5 months old, and adults were greater than 5 months. So this were the 127 animals which were adult were adopted by far in 2022, and puppies who were babies only 166. And what was the average intake and average outcome age of that particular animal? This is specifically for dog right now in this snapshot. So this is the ages in months, 17 months and 20 months. And also we have specified here for kittens, cats. So adult by far 14 were adopted, and 14 baby kittens were adopted. So the next one, this one is kind of like a performance dashboard. So this table, you can recognize the one which Shalini has shown you the report. So this is basically just to give them a visualization purpose. Rather than report, we also provided them this live intakes and live outcomes. This is defined by age categories and different age groups of the animals. So they have around like 6 categories of different animals defined in their sheets. So we use those categories, and so that they can aggregate and count like how many of those categories of animals are rescued and how many of them were getting adopted. So as for example, for transfer outstate, you can see 2,263 animals were rescued, but 2,170 animals out of those 2,170 were the ones that were adopted. So they can see the aggregated calculations of those animals, because they specifically wanted to see those categories, and they wanted to see how far they are doing with live animal intakes and outcomes. So they can even, as you can clearly see at the top, there is year, quarter, month, even species filter over there. They can do multiple selections easily, and they can check it for different years, different quarters, different months, and even for, because we did it specifically for cat and dog, so only 2 of the species were available in this section. So the next snapshot is animal adopted yearly comparison. So this was basically for animal intakes, means animal rescued. Okay. So, and also they wanted to see days in foster. So this was for the days in foster and animal adoption fees by far, and the breakdown of the animal adoptions by different age categories, how they are doing by every year. And the next one is basically explaining the animal intakes by different age groups and different size groups. As you can clearly see, 1 to 3 years old animals were most popular, 47%, and with 40%, the animals with less than 15 lbs were most popular. This is with the breed. So terrier was the most popular breed. Almost 1,100 animals were rescued, and 1,100 of them were adopted in 2022. And this is defined with different adults and babies and how they are performing in different quarters. This was the snapshot where you can see the receive date of the animals. You can filter out on the basis of receive date, the status of the animals, whether it's adopted, available, euthanized, the size, age group, species, breed is according to, if you're gonna, because this is a responsive dashboard, so if you're gonna click on one thing, it's gonna automatically show the data corresponding to that particular filter that you have applied. And here you can see the different rescue counts by year and species. Similarly for the animal counts with different breeds, like how many, which breeds are more popular. This is the similar snapshot by different age groups and categories, and this is through United States, which state is performing good in terms of animal adoptions and rescues. The next snapshot is basically for average days in fosters by different age groups and different age categories. They wanted to see which animals are averagely more staying in the foster care, and why they want to analyze that data, like why they are more in the foster care. And so they wanted a snapshot for these, so we created that for them. And this one is basically the rescue counts and average days in fosters, like state-wise, different states in the United States, which state is most popular. The Minneapolis city was the most popular in terms of dogs and cats, so as you can clearly see over there. So I'm gonna be calling Andrei for the rest of the slides.
Hi everyone, my name is Andrei Jula. I'm gonna cover the second out of three stage framework. One of the challenges that a business analyst is facing usually is losing track of the end scope. What are we doing from the data entry all the way to the insights that that data can provide for the customer? As a challenge, obviously, simple questions such as what happened and what is currently happening there's a lot of work, there's a lot of effort that's put into coming up with a dashboard that it's live, it's constantly getting updated. It's got all the processes baked into in a way that the team can actually make use of that data. So we can get lost in a lot of the technicalities behind all that, but if we keep in mind what's the end goal, then I think that would help us, even identify the better models and how we handle and how we create that. How do we help the customer understand their own data in a better way? We did have a couple of wow moments, so that was a good takeaway from the project. And then there were some models that were just reinstating the obvious. And I'll go through that in a little bit. But most of the work that is going to be shown from here on is in the predictive section, which means it is definitely built on the data that was historical and current. The prescriptive part is definitely out of scope. There's so much more to that section as well. And everything started from a key influencer visual that's currently available in Power BI. For example, what influences average days to adoption, to decrease or increase? And these are some of the questions that the marketing director was asking. How can she tackle the demographics? What kind of breed or what's influencing that metric to go up or down? So as I mentioned, the key influencer is out of the box. But as David was mentioning earlier in a presentation, is you don't have control on actually what is happening there. So it's great to see some of the metrics, presented by, just out of the box to say if it's a dog, or if the breed is a pointer, or all of the other dimensions, values of a dimension that can go into that. Many dimensions, actually. And then what influences days in foster to increase? So, for example, where can we improve in decreasing that? But you want to see what's behind that. So this was all great, but being out of the box we were not comfortable to just provide that. So we're trying to mimic that with our experience in writing Python scripts, and this is where this work comes in place. The reason I'm showing this slide is Python can be written in all of these stages, but we concentrated on step 4, 5, and 6. 6 was not part of the initial plan. It was kind of like a backup plan to say if Power BI cannot house everything that we need to provide that interaction, which is live, that's what the users love, instead of having a person that's fully dedicated to interpret the data and all kinds of charts and graphics. That's where the local application was a good success, and then the published as a web interface application of everything we've seen in the previous slides was the bread and butter of this project. But then some Python code that was able to be ran into the DAX, into the load script, and then some Python code that was behind the objects in the application were okay, but not great. So we, for that reason, expanded the scope of the project to go into what we're familiar with. I'm not saying it's the best or worse. I don't have any actions in any other companies, but Google Colab was the next comfortable environment to work with in Python. And here are some pros and cons. I'm not going to go through all of them because the time's short. But and that's when we got into the trenches of, well, now it's not just a shiny object in Power BI that can just spit out all these findings and insights. So we started to look at the data and get very close to the data. So here's just, again, high-level data pre-processing, imputing values, understanding correlation, heat maps, histograms. We had to consolidate the datetime for some of the models in, for time sensitive, for models that are using sequential dates. And then we converted some categorical values to numerical. This is all done in Python. The one takeaway that, at least, learning lesson for us was the one hot encoder versus the encoder, the label encoder was a eureka moment. To understand that the data is not ordinal, so the direction would not mean anything. Lower numbers do not mean lower weights. So for that reason, you cannot have everything in one column. So the one hot encoder is exploding that in multiple columns, so you can actually assign the proper weight and equally, distribute it for each of the categorical values. There was some effort put into understanding the data and correlating that to the different data models that we can run. Here are some examples: the linear, polynomial, decision trees using the Gini and entropy as classification trees, regression trees, and then we got into the simple neural network and then LSTM. So this is just an example where Python can be run into the DAX, into the load script. It generated tables, new columns, so all great, but it was not what I initially envisioned, to have a lot of the processing that's done through running, let's say Python code in Google Colab, and being able to just save that and then retrieve it, so when people click around throughout the dashboards, you don't take the time to wait for 5 minutes for a model to run. Well, eureka moment, that could not be done for many reasons. You'll see a slide down the road. The one thing that I did not like was the lack of good an environment where you're parsing that code. It was just not friendly. This is the Python code that you can run after you go through some technical, especially with the application, you got to have all kinds of DLLs installed and all that. So Microsoft integrated that with Microsoft Visual Studio or Visual Studio Code. So this is where it's coming closer to other environments that maybe some of you are familiar with, let's say Spider or Google Colab, where you can see it's just a better parser too. It's a strange way of where the code is running, it's saving some temporary files, and it's giving you feedback that it did run correctly or not. And if it did, you go copy paste and you put it back in here. So clearly there's some work to be done there, but it's there for you to use. These are some simple Python objects in the dashboards. So you can easily click around your filters and try to understand, for example, what it means to select 2022 versus 21. How is this getting updated on the fly? So that's great. The problem is a lot of that stuff cannot be done on the fly, so this is where all that work moved on into Google Colab. Here's just an example of some polynomial regressions, pair plots, correlation heat maps, so just some obvious, facts about that, but it's just a person in that environment is not able to look at this and understand what does it mean to look at any of these numbers. So it's just not a feasible setup where a business analyst is just with the group constantly to just answer simple questions. Now, some of the findings are, common sense. For example, a positive 0.29 value for days to adoption versus age at adoption implies that the time for a rescue to be adopted increases with age. That's just because of the correlation and the positive direction of that. And the negative is the other way. So if the age, the older, it's less kid-friendly. So that's just, I guess, common sense. But this is statistically, shown that it's real. We use decision trees. Again, Gini, entropy. This is just an example of a pruned vertical decision tree where we got decision trees are really good in many ways, and it's got some drawback. They have some drawbacks, but it is a supervised learning algorithm that can be used for both classification and regression tasks. They're known to be immune to outliers, so we didn't have to play too much with the data prior to running that data into these. Here's just another example. And then once you have the predicted values, how am I doing on time? Is it good? You have the confusion matrix. Again, some just widely known KPIs. But it was interesting to see. Okay, so this is where we saved. So the intention to save the model was to not have that model run as the person clicks around the application. We used the package for saving loading models, Pickle. Here's just the code behind that. What was interesting is prior to saving the model, the confusion matrix had those numbers segregated. After being saved and reloaded back into the script, we just wanted to see exactly how does that saved model behave once it's reloaded. It was interesting to see how it got consolidated in one. It did not change the output of the predictive part of it. This is just an example where the simple neural network, definitely there was a trial and error to understand how the different activation, the layers, the neuron, pretty much this was kind of like a dashboard where you would play with all these optimizers and momentum and the categorical cross entropies. And okay, I'm not going to go through that, but this was the output. So we kind of kept track of the lowest MAE, the lowest loss, and then we found that the data was not really that supportive. Hold on. Sorry, guys, but yeah, this is pretty much it. Okay, and this is my dash on Patrick.
Okay, thank you. So, as you can tell, the students are very eager to get into the nitty-gritty. They wouldn't let it go. So, so at least I wanted to save a few minutes to kind of have a Q&A. If there are any questions or drill them. Yes.
So, what is the outcome of implementing this solution, actually? So, what is the outcome of implementing this solution at the end of the day, actually? So, how did it help the SHS?
So currently, the team has the published dashboard as a web interface. They can actually go there and just create their own drill downs. That is exactly what they expected, right? Something that it's self-sufficient, and they can cater for that data to themselves. The only thing is some data is manually exported from those systems. Everything that's automatic, it's there, it's automatically reloading every night. But the data that's static requires that, let's say, weekly for a directional vision of what the tool can do. The Python part, if they can hire any of us, we can help. But it's a wish. It's on a wish list for now.
Yeah. So one of the main benefits that they got was, remember early on they showed a report, a very simple report. They do it manually. And so they have to file that report in order to be compliant. So they have to report that so that they can apply for external funding and things. So they have been very lax in terms of filing those reports. And so having this kind of all automated, now they're able to generate the report and then file it so that they can say we are up to date in compliance and so give us more money. So that's one of the main advantages that came out of this project.
Great presentation. How long did it take for you guys to complete this project, beginning to end?
It was a semester's work.
Semesters.
Put them through the ringer, so they don't get off easy.
Plus few more days.
If I understand correctly, you used Python, kind of your ETL, to extract the data and transform it. Is that right?
Python was used for analysis. ETL was done in Node.js.
So my question is, why you didn't use the embedded M language in Power BI?
Like I said, there was a lot of data discrepancies. We really had to clean up the data. Python could do something, and he had pushed the data to us. And we were two projects, so we didn't want to make all those changes in Node.js itself. So for us, we wanted the data represented in certain way for the outcomes report that they had to file to the state. So that needed a different combining of tables, etc. So project-wise, we thought we will split it at that level and keep a master table so that both the teams can access, and this can be accessed by any team since it's hosted. And we just kept the raw data. So any team that wants, to do further analysis, add more tables, they can add it to the master, which is sitting on Amazon and Amazon Web Services. And then you could do more.
Azure now.
Azure.
That was the first step.
Yeah. So we wanted to keep the raw data raw and then do the analysis when we want to, so that this is not going to stop. It was us, Oakland, this project today. And this is going to continue. So we wanted to, leave it at that stage so that other teams can come up and take the places. So that was the main idea.
The other aspect is also being able to build predictive models as well. So that's where the Colab notebooks and all the machine learning models that comes into picture. Even though they did not ask for that, because it was sort of an additional stretch goal that we set for the students. Hey, you have taken a course in deep learning, intro to data science. So apply all of those things into this project. And so the long-term goal is to be able to build these predictive models so that we can help them to kind of know how many animals are going to come in for the next year, or how much donations do we need, so to get a better sense of their planning ahead. So far it's mostly reactive. Oh crap, we got all these animals, we got to do something with them, right? But in order to be more efficient, if they can peek into the horizon and get a sense of what's coming down the pike, they would be better prepared. Yeah, so exactly. 1 minute.
Yeah.
Hi, I teach master's data analytic courses through another university. So my question is, based off of what classes you have learned before you did your capstone, when you got your capstone course and doing this project, what was something that you felt like you needed more information on that was a struggle because it wasn't more in depth in the classroom? Correct. Was there anything that was like a deficit?
It was new to me. In my workplace, I use Tableau, and we had Tableaus in Coursework also, but Power BI was new to us because we picked Power BI because it would be simpler for them, and I think they had some Microsoft coupons or something, so they preferred that too. So we had to learn it. Well, it was not completely new to us, but we still had to make adjustments, hosting it on a server. Those things are totally out of the coursework. So real-time world situations needed some out-of-the-box work.
And also talking to people, extracting what is in their minds. We had a lot of meetings, because that's something that we cannot teach in the classroom. So that's why we throw them under the bus, let them survive. Exactly, Yes. Dave, yeah.
One of the things I myself see a lot in Data for Good, I've helped with a project or two over the years, is the way people get connected to a project is they start with a group that they're already working with, already volunteering at, and then say, oh, well, for example, the first one I ever did was for Habitat for Humanity, and I was banging nails for them. But then I did a forecasting project on how to find more donors and volunteers. Was that the case here? Were you already working with this group? Well, how did you get connected with them? How did you know this particular one?
Thanks to Professor, and also the idea about dogs, I guess, because I have a dog, I'm a dog parent, I think he's also a dog parent. So this is something which obviously keeps on motivating us, and we wanted to help them because they explain us what what they need was just an Excel file to be automated. So that was all our idea, our professor's idea. We wanted to automate more things for them, and they wanted to use this so that it can be actually beneficial for them in future, and they can even use this thing and even advance it more.
But it still started with something that meant something to you. You wanted to do something with dogs, and then the project.
Right, yeah.
yeah.
So this was actually through the SAS connection, Dave. So, people that worked in SAS have sort of reach in the community, and then we were talking about, Data for Good projects, and so this kind of came about through the conversation. So, yeah. Meeting with analytics groups and stuff, yeah, exactly. Any other question? Yes. I guess Octavia is going, get out of the room.
So my question is kind of related. I attended Dave's session this morning, and he did mention Data for Good briefly. So I'm trying to understand what's the connection. So it's like a movement of some sorts related to data and analytics, and you pick projects based on, okay. Can you expand more on that?
Yeah, so, like you mentioned, we have strong partnership with SAS, and then Michigan SAS user group is quite active as well. And so, people want to do, community outreach and help nonprofits mostly. And so there are groups of people interested, and so we can get connected, and, people looking to accomplish tasks that they don't have expertise or time. And so that's where we come in to help out. Yeah, so it's a win-win situation. Yeah, exactly. So thanks, everyone. Thanks for all the wonderful questions and the feedback. Thank you, team. Good job. Very nice. Very nice.